who is the head in the Weather and Climate Research Group, NAR, National Atmospheric Research Laboratory, Gadangi, Tirupati. He has completed his doctoral degree at Pune University, and he started his career in IMD, and then he moved to CDAC, Center for Development and Advanced Computing in Pune. Then he joined in NAR, National Atmospheric Research Laboratory, as a scientist. Now he became the head of Weather and Climate Research Group. He has visited many countries, and our distinguished speaker involved all ISRO satellite launches, and he is the main coordinator of weather pattern analysis during the launch process. He received many national as well as international awards. To his credit, he has more than 100 such publications in all highly reputed journals. And the major point is he is the first person in India to simulate the air mode model. From him only we learned how to simulate that model. And he is my well-wisher, and he is my boss for climate modeling and simulations. Today we are fortunate enough. Today we are fortunate to have Dr. Amit Kesarkar. He is a scientist, and he is a excellent for excellence nationally and internationally in tropical cyclone as well as in the supercomputing. On behalf of this UGC STRIDE organizing committee, we welcome you, sir. With this short note, I hand over this session to Dr. Amit Kesarkar for further proceedings. Thank you, sir.
Thank you very much, Vijay, and thank you very much, organizers. You have given me opportunity to meet many of young students, and I understand from you that most of them are PhD scholars. So I am very happy to with them, and definitely we will try to see next one and a half hour how we can know about little bit about the cyclones and how they will be benefited out of this practical. Most of you are from life science, that is what I understood, and then I will go slow. And if you have some questions, kindly raise your hands and please let me know. We will have an interactive session. With this, I will share my screen. You are able to see my screen?
Yes, sir. Yes, sir.
Okay. So now we will start about that. So I I feel most of you might have most of you knows about the tropical cyclone. At least might have heard in the newspaper and all. But it is very important topic which is of socio-economic important, and definitely under the changing climate scenario it really gives a lot of concern. So I thought that we will talk about it with all of you, and then we will do some little bit practical based on that. So basically, this is our we are working on tropical cyclone more than a decade, and some of the results from some my PhD student like Jyoti, Rajashri, and Pampi, we will be presenting to you. But before that, I will be giving a brief introduction about the subject. So you might have heard like a tropical cyclone is a very big system, and if once it cross coast, it damages the many buildings, poles, plants, and all. So have you ever thought how much energy is involved in that? So if you see the energy of the tropical cyclone is of the order of 10 raised to 12 to 10 raised to 22 joule, and therefore this much energy how it generate into the atmosphere is a big question. For give some idea, if you just wave your hand, that will be of the order of something like zero point 0.1 joule. So you can think like a 10 raised to 12 to 10 raised to 22 joule energy has to be brought in, so that a tropical cyclone has to be formed. So initially, it is known that tropical cyclones are formed from the instabilities, but how this instability increase to the very large extent to give such a damaging thing. If you see the amount of wind shear or uh, uh, amount of wind shear and amount of kinetic energy it generates, that will damage the most of the structures across the coast. So let us understand how things are formed and how climate change will impact on this. So to give an understanding, the cyclone is divided into I region, then followed by rain band region. So it looks like this. So this is eyeball, this is another eyeball. Now there is two terms. One is primary circulation, another is the secondary circulation. All of you know that circulation is a motion of a wind. So primary circulation is known. This is a primary circulation is shown in the yellow curve. This actually happens because of some low pressure area formed in the atmosphere, and when that low pressure area becomes strong enough to have a vertical circulation, which is known as a secondary circulation, uh, uh, then we call that as a tropical cyclone. So it is a rapidly rotating storm and characterized by low pressure at center and close low level atmospheric circulation with strong wind and spiral arrangement that produces the heavy rain. So now idea is, if you might have traveled by flight, most of you might have definitely. So you might have seen such a small clouds, then some kind of thunderstorms, and then the cyclone. Uh, so basically, from this kind of small, we call as convection. All of you know that energy transfer in three forms, like conduction, convection, and radiation. So in your 12th standard or so, in your degrees, you might have seen that convection is physically movement of water, and you might have given that example. Similarly, in atmosphere, the physical movement of air is happening, and air from the surface goes into the aloft, in the sense that it goes in upper atmosphere and get condensed. Sorry. So that then once it get condensed, this kind of clouds forms. Now these clouds, they basically form and they release. All of you know that once anything condense, it releases the heat, and that heat gets accumulated, and slowly this moisture start get condensing and the form a bigger thunderstorm, and from this such as so many thunderstorms come together to form a cyclone. So this is one of the most important problem. And if you see, this is a satellite picture which is showing the center of the cyclones constant, and continents are moving, in the sense that you will see that these blue or green dots, they are then they becoming red dots and finally merging into the tropical cyclone. So this is how many of the thunderstorms, they are coming and forming a cyclone. So once you have a low pressure area like here, so many of such thunderstorms comes together to form a tropical cyclone. So this is how the tropical cyclone forms. But most of the people worried why these things happening in the atmosphere, because why particular low pressure area has to form at one place, why particular uh, uh, time that cyclone has to be formed, and how it forms, how it intensify, how it's decay, and why it damages the so many structures around the globe. These questions were highly motivated for the disaster management, but there are one wing of scientists which actually was looking after the theoretical development, and we have also worked on theoretical development of the tropical cyclone over the years, and we have come up with a lot of new theories. We will be discussing about that. So fundamentally, what we are trying to understand is what is the mechanism of accumulation of many such level of energy at the center of the tropical cyclone or the center of the low pressure area, so that it will form such a disastrous system that cause. So initial studies like in 1968 and all, people identify that sea surface temperature is one of the most important, where the sea surface temperature more than 26 degrees centigrade is there. Their evaporation of the water vapors are more, and they form the tropical cyclone. Similarly, the difference between a shear between two different layers of the atmosphere is important. Similarly, there are many such parameters were identified like conditional instability or vorticity and all. So vorticity, we mean that how particular rotation is taking place of the airflow, and many such parameters were identified, but still uh, it was very difficult to tell them, because these are the necessary conditions but not sufficient. These conditions may occur at one place, and but which actually doesn't give rise to the development or the genesis of the tropical cyclone, uh, uh, and so on. Uh, so uh, that is one minute. So that was the problem taken by the theoretical scientists, and then many studies have carried out. So this is one of my student Rajesh's paper where we have published how sea surface temperature. These black dots are indicating the occurrence of the tropical cyclone or genesis of the tropical cyclone, and colors indicating the sea surface temperature, mid-tropospheric relative humidity, and vertical wind shear. And we could find that where the shear is less and where the mid-tropospheric relative humidity is more, and sea surface temperature is high, cyclone is forming. So this thresholding is there. So at different seasons we could find, and we could found out threshold for the Indian Oceans. But most important problem was still remain how these small scale systems, like I shown you the figures in the figure, where this kind of systems come together in a cluster and then embed into the wave and form a bigger cyclone. So the problem statement was the pathway by which cumulus convection organize. Now cumulus convection, we mean that how clouds form. Cumuli clouds is another terms of cloud, which is tall cloud, which gives rise to thunderstorms or gives rise to the cyclone. They form a large scale vortex, which is a great unsolved problem, and over the years people tried to solve it, but it could not solve. So there were three paradigms in decades. So first one was the conditional instability of second kind. So conditional instability of second kind was proposed by the Charney in 1964. So 1964, he told that there is a possibility of development of tropical cyclone if some kind of cumulus convection is there, and or near to that cumulus convection, lot of moisture comes together, what we call as the low level horizontal convergence, and then that can form, means the most of the thunderstorms selectively at selective locations come together to form a tropical cyclone. And there, why they come together? Because there is a release of a potential energy available for the convection. So this was first theory, and it was well established during that time, and it was well discussed in the literature. But what happen is, if you see the energy in the atmosphere is of the order of 10 raised to 6. So if thunderstorms has to come together, then we should have 10 raised to 6 or 10 raised to 5, those many thunderstorms together to form a low pressure area of having energy of 10 raised to 12. Then whether it is possible or not. And most of the people argued that this is not possible, and because of that, a new theory has come. Then everybody was thinking that is it because of from where that energy is coming? Is it because of atmosphere alone, or the ocean is also playing an important role? So another theory, which is called as wind-induced surface heat exchange, was written by Kerry Emanuel. Kerry Emanuel was the MIT professor, and then he brought out that theory. He argued that there are a lot of energy in the ocean, and that ocean, because ocean has a high specific thermal coefficient, and it can sponsor a lot of energy to form a cyclone in the atmosphere. So if the lot of energy is sponsored by the ocean, then it can form. And then, because it was discovered that about 32 degree centigrade, this particular tropical cyclones are about 26 degrees centigrade, tropical cyclones are formed. Then he found that it is a sea and air, they exchange, and they wrote a theory of in 1986, saying that if stratosphere is something like about 20 kilometer at tropical latitude. So from 20 kilometer and at ocean, the temperature difference divided by stratospheric temperature, that difference is more. Then they define that as the efficiency, and then they told that the intensification is basically happening where tropical cyclone gets the energy from the ocean, and that forms a tropical cyclone, and how the energy from the ocean to the upper atmosphere is transferred through some kind of instability, and they form. Both theories were assuming that we should have some kind of initial rotating system, and transformation of small thunderstorm into the bigger thunderstorm. And this was the celebrated theory for over the years, and this theory was useful to um, explain monsoon circulation and so on. So many of this thing was well produced, and people were thinking that we have a theory of a cyclone. Still there was lacuna, and we were not able to explain why tropical cyclone forms in a way at particular location, because where we we try to understand that why at particular location only, that and particular time that tropical cyclones originates. So another theory was proposed by Montgomery, and this theory says the merging of many thunderstorms, we call them as a vertical hot towers, they form a uh, genesis potential for the thunderstorms. Now I will explain about this more details. So he says that yes, energy is coming from the ocean, but cyclone is not formed from the one thunderstorm which will bulge into the tropical cyclone. Because to give an idea for you about the sizes of thunderstorms are from 1 kilometer to 10 kilometer, and if you see the tropical cyclone size is from 200 kilometer to something around 1000 kilometer. So such a big a disturbance in of a radius of 200 to 1000 kilometer we cannot form with the 1 to 10 kilometers. So there should be some other mechanism, and therefore Montgomery says that the vorticity or the convection is not taking place at one place but at many places, and these three paradigms were celebrated in last 6 decades. This is most recent one, 2006, and then form. So this is something like first theory, where I will just explain you. Initially, some low pressure forms, and once it low pressure from the ambient air enters into that and slowly convect into the atmosphere. Now as you go up, you might have gone into the plane, that time you will be around 10 kilometer, they are saying outside temperature is minus 40 degree. So as you go up above 5 kilometer, you will see that around 5 kilometer you will reach to the 0 degree centigrade, where the actual water vapor into the atmosphere turns into the liquid, and it will turns above minus 40 degree, it turns into the ice. So you will able to see the clouds, and it they form. So initially the low pressure area supposed to be there in the first area, and the air from the many surrounding comes to uh, due to the low pressure area and get convect, and this convection, this air forms a cloud, and this cloud keep on becoming stronger and stronger as it go up. The heat release here, then the difference of temperature between sea surface and heat here increases, and this become a stronger and stronger. So this is how the uh, this theory, Oyama and Charnes theory of conditional instability of second kind forms. And because of the Coriolis force, you may be aware that because of Earth rotation, there is pseudo force acts on the everything on the Earth, that is known as Coriolis force, and that because of that force it start rotating and have a very nice tropical cyclone develop. So but there was a question was asked, why then thunderstorms form a line, not in a circle? And there were many such objections were raised by the many great scientists, and the limitation of theory was discussed over the year. So another second theory was wind-induced heat exchange, where Emmanuel and all this is suggested that first some mid-level, middle means a mesocyclone at about 5 kilometer, it precipitates and forms a downdraft. You might have seen that if thunderstorms occurs nearby region, you will get very cold wind, and that cold and moist wind which is coming from the rainfall, they comes together and form small scale thunderstorms, and they come together. This mesoscale meso so what he is told that first this mid-level mesocyclone has to form, and then small scale thunderstorm has to form, and they come together to form a cyclone. So This was the total theory. In 1986, 1987 was written by the Bister and Emmanuel, and based on this, many things were explained. But both theories were initially assuming that there is some kind of low pressure area or the mesocyclone form, but nobody knows without anything how this particular cyclone will form. Now, uh, now in concept of uh, aerial vorticity means what happen is if some air, you might have realized also most of the time, once lot of air moves in random directions, any when thunderstorms are there, when down drops are there. So the concept of these concepts was used by the Montgomery and said that if there is nothing but a slight low pressure area form in some kind of wave, and thunderstorm developed at different places, then there will be a some this because of the formation of so many thunderstorm ground drops coming from so many thunderstorm create a random motion of air initially, and slowly they get organized, and so many thunderstorms comes together to form a aerial rotation much more larger to form a cyclone. So these kind of thunderstorms also called as the cumulus conjunction cloud, and they are visible through satellite. So this is validated by satellite pictures also. You might have heard about TRMM satellite and all. And these satellites, towering clouds, they comes together in the cyclone, was also verified by the scientists, and they say that these vertical hot towers comes together to form a aerial vorticity, high aerial vorticity, to form a tropical cyclone. So what happens that these thunderstorms collide with each other, they merge and increase the lower level velocity, or we call as the spin up, to form a cyclone. So we did lot of study, which is the role of this particular vertical hot towers in cyclogenesis. For that purpose, we have studied many cyclones, and we trace back how they form, inside the wave, and how we can trace them about 15 days prior to that. So it is something like in a wave, a particular area form we called as the genesis area or the ingestus area, and that area, the moisture and rotation keep on accumulating, and the particular area is such that it will allow air to enter horizontally but does not allow to go out. In such a situation, air has to go upward, and because of that, a particular tropical cyclone forms. So this is something like a clustering, reorganization, and merging of these vortices. They comes together to form the cyclone, and these are some of the papers we have shown that how the merging of mesovortices to give rise to the tropical cyclone. So whether this theory is perfect or not. So if you see, theory answers the most of the questions. Actually, we have published more than about 20 papers, but still theory is not perfect, because some of the questions like how ocean interact with the mesovortices, or what is the actual rotation speed of mesovortices, because this is something theoretical development. Whatever you are seeing is coming from the equation. We don't have direct measurement inside the tropical cyclone, either from satellites or in situ. You cannot sustain into that. So whether these theories are useful, it's or it is just like a mental game. But what we could show that the how tropical cyclone move, when it will form, we could explain by simulation. But what we want to do is we want to really measure the winds through satellite inside the cyclone, and technique is getting developed, and over the years a mission will come which will actually measures the winds, and we will able to understand what is happening inside the cyclone. But with the theoretical understanding or theoretical modeling, we could come out with the most answers of most of the Hmm, questions. So this is all about how cyclone genesis. I am giving you this background because we will see how climate change will impact on them. So another thing is something like a how cyclone tracks move or the cyclone moves. If you see, cyclone is basically move at particular direction, and if you plot from 1840 tracks of cyclones, and these are called as best track data. They have they actually form near from near to equator till about 20 degree, they impact, and these are the various tracks of cyclone. If you see, here are only few cyclones there in South America, South Atlantic Sea, and otherwise there are many cyclones occurring in Indian Ocean, Pacific, and Indian Ocean and South North Pacific. So basically, what I wanted to show is tropical cyclone. They form somewhere here in the wave. This is called as ITCZ, and this wave, the from this wave, something like this, all thunderstorms comes together, and then they merge here. You can see, and that merged thing forms, then it isolate from the main structures and it come and hit to the continent. So this is how tropical cyclones moves forms, and then they moves towards the continent. So weather changing climate will impact that. So if you see the changing climate, um, so all of you know that climate is changing, temperatures are increasing. People are saying zero point 0.7 degrees centigrade, and some people are saying there may be 4 degrees centigrade. So many things are predicted. But this is also a, at this moment, equations game. So tomorrow, if you change the equations, the temperature increase in the temperature and increase in the sea surface temperature, or the increase in the level height, all these things will change. So we need to know the what is the best scenario. So what is the worst scenario, and that is where you have the RCP protocol and all. But most importantly, if you ask me whether the models are perfect to explain them, whether we have entire data to characterize them. So if you, as far as the tropical cyclone concern, it's very difficult to have total understanding what will happen in uh, future. So when in 1998, when we started the actual modeling in India, that time people used to say by 2020 Mumbai will be submerged into the uh, totally into the sea, and then Mumbai will not be there in India's map. But if you see, really, that was the worst case scenario, and then there are many such events were predicted where worst case scenario was presented, and then many protocols came, and there was many restrictions were made, and then people say that we could stop the global warming. But if you see, the many politicians, they may not agree to your sentence because it's like a theoretical minded. So what is the most important when we are doing the climate change study is we have to prove that whatever we are saying is happening into the no, with the known data or the historical data. So many times we have to compare our result or the run our models to previous years models or the historical data model, and from there, once they are coming correct, then we can say we are well to go about. Now the models much more fine tuned since 1998, and we have a better understanding, but still we need to get a better credibility, and therefore the lot of development into the modeling is very much important. Now, if you see the tropical cyclone motion, which we were seeing here from the data, has to be explained with respect to tropical cyclone observation and the simulation. If they are very well, then we can use that for simulation of simulation. So there are many such a model. We have also our own model, and we could come out, and the understanding we got into that is anthropogenic warming will actually slowing the motion. So fundamentally, if you see, if sea surface temperature is rising, definitely it is going to affect cyclone. If mid tropospheric relative humidity decrease due to the warming, will that will have a negative impact on development of the cyclone, and so on. Therefore, the motion, whatever coming from the equator towards the pole, this motion is after model simulation of something like 120 years, we could say that the anthropogenic warming is slowing the tropical cyclone motion, especially in the mid latitude. This cause the slowdown of poleward shift, and uh, the motion, tropical cyclone motion here, it will affect the tropical cyclone or the areas, affect the people in the areas of Asia, North America, and all, because tropical cyclone are decelerated and they are not going fast towards the pole. That means that over the lower latitudes there will be lot of rain, and that forms a tropical that forms a damage the potential in the lower latitude. So this is a study. This is recently published in Science in 2020, and if you see, this is at this moment with a lot of assumptions, and we need to really look into where the young researchers like you have to come up with fundamental thinking, fundamental understanding to give the credible results for society, so that the damage potentials of these cyclones can be identified, damage potential, especially those who are doing into the life science, they can see into the ecological aspect or something like phytoplankton and other things, how they are affecting, or whether phytophytons affecting on these topics. Again, so many things can be done if you can understand how tropical cyclones have formed, they form, and then how they move. And that theoretical development we are working on at this moment, and some of the results I will be presenting. So most important thing is this motion. So what we understood from the tropical cyclone theory, that anthropogenic warming will definitely have an impact, either either changes in the sea surface temperature or either in the air temperature will have an impact, and they are decelerating, and this decelerating motion will impact, will have a disastrous impact on that. But there are other factors which actually forms into the tropical cyclone, something like a rapid intensification. So what happened, the tropical cyclone uh, actually develops within the 7 days, but suddenly if you see, in a one day it will form, it develops from one lower stage to very higher stage, what we can say is category 1 to category 4 or 5, such that the surface wind flow is something like 15.4 meter per second to 30 it goes within a increase within a 24 hours. To give you idea, 15.4 meter per second is very huge wind speed, this wind change. It can actually uproot the coconut tree of that order. For example, if 5 to 6 meter per second wind actually cause the all cloths and the peppers to flow in the air. 15 is much more, three times more than that, then it can uproot that. So sudden change in the tropical cyclone intensity, and what are the different factors affecting that, we have studied. And this kind of various intensification and changes in the motion has to be studied before concluding that what will happen, whether tropical cyclone will decelerate with the anthropogenic warming and all. So this is one of the our paper at this moment. It is in review of the climate dynamics, and we have seen from 2000 to 2018 we have studied the 15 number of tropical cyclones which undergone the rapid intensification, from example from depression to severe cyclonic storm stage, and these are the various stages like deep depression to a very severe cyclonic storm to very severe cyclonic storm to extremely severe cyclonic storm, and super cyclonic storm. And if you see that maximum number is happening from cyclonic storm to very severe cyclonic storm, and severe cyclonic storm to extremely severe cyclonic storm at different. This is the circulation over India during pre-monsoon and post-monsoon season, and how it affects. So we have done the analysis of lot of data set, and we found that now I will show you this percentage, means the percentage of tropical cyclone intensified as a rapid intensification, or the has shown the rapid intensification in their life cycle. And this black line is showing total number of tropical cyclone, and then this violet line is number of rapid intensified tropical cyclone and linear trend. So if you see that over the Bay of Bengal, the total number of tropical cyclone genesis is decreasing, or over the Arabian Sea it is increasing. Then another thing is this is over Bay of Bengal, Arabian Sea, pre-monsoon, post-monsoon, and annual. So this is pre-monsoon, post-monsoon season. Uh, uh, Sorry, this is annual, and this is pre-monsoon, and this is post-monsoon season. So if you see, annual trend is decreasing over the Bay of Bengal, but if you see pre-monsoon trend is same, but post-monsoon season trend is decreasing. So if you see same thing for the Arabian Sea, you see that pre-monsoon cyclogenesis is increasing, as well as post-monsoon cyclogenesis is increasing over the Arabian Sea. So, and rapid intensification also is seen in the most of the. For example, this red column shows 100% of tropical cyclones shows the rapid intensification. So, which actually contradict the many of the results suggested by the theoretical development, and we need to look into those perspective why models goes wrong, and we need to improve their capacity or the capability to predict in the future. Because if we don't do as a scientist, because most of you are the research scholars, and then you will be scientists soon, and then if we are not able to credibly deliver the understanding what we have to the because politicians will not believe or the policymakers instead of politicians, we can say that they will not believe to you unless you prove that what is observed. And this kind of rapid intensification, rapid weakening, and there is something called as eyeball replacement cycle. These three three mechanisms which occur during the motion of the cyclone really gives a challenge for most of us to refine for theory further. So for that purpose, we need to look into very minutely what is being developed and go further. So we could we have analyzed. So people were saying sea surface temperature is very much important, but one of our paper in climate dynamics we could show that instead of sea surface temperature, there is something called as ocean mean temperature is more important, and then cyclone moves where the high ocean mean temperature is uh, there. Now, what is ocean mean temperature? Sea surface temperature is just surface temperature, few millimeter depth, but ocean mean temperature is uh, is a depth where whatever may be the sea surface temperature from there to the height where the sea surface temperature is 26 degrees centigrade. That height ranges from 1 meter to 100 meter. At different season it changes, and that gives actually interact with the atmosphere. What is the physical mechanism behind that? Even the top sea surface temperature is cools because of the cyclonic rain, but the bottom sea surface temperature is very high, and mixing takes the time, and that high temperature again hits the sea surface temperature and in the neighborhood, and then forms a give rise to a tropical cyclone. So many of these things are seen. Similarly, we have seen that the averaged RH. This is one of the my student competes in her PhD thesis work, and this is also getting published in another paper in climate dynamics. So if you see that. If you see the composite or if you study all these 15 tropical cyclones together, and then what happened, because what leads to the uh, form, what leads to the rapid intensification, if you analyze, then you will see that there is an increase in the boundary layer wind shear, and there is increase in the mid tropospheric decrease in mid-tropospheric humidity or mid-tropospheric relative humidity, and then there is a the deep layer means from 800 HP to 200 HP increase in the wind shear, and these various results we could find out, and then we could see that whether whatever we are guessing in the theory is correct or not. This is basically a um, spatial distribution of composites, means how particular, if particular cyclone is undergoing rapid intensification at 00 hours. 00 hours means some hours, we consider that as a 00 hour, and how previous 36-hour transformation is taking place for all 15 tropical cyclones together to form a composite analysis. This kind of composite analysis is used in climate change studies for various purpose to understand the physical mechanism how the climate change will impact, and this we have analyzed, and we could find that decrease in the vertical wind shear and sufficient increase in the mid-tropospheric increase in the is seen in the rapid intensification period, and we need to prove in our modeling efforts also. Similarly, if you see the composite of upper layer divergence and composite of vertical wind shears, total precipitable water, there are the changes are seen. So this is not for the particular cyclone, but it is the combination of many cyclones, in our case 15 cyclones, to generate a knowledge about those phenomena. And once this knowledge is there, then we can verify that. Similarly, composite of diabatic heating, you can see increase in the diabatic heating as well as the precipitable water at the center is seen. So basically, we come up with the theoretical understanding. There is an increase in the diabatic heating with the maximum value of 50 Kelvin per hour. Means you think of in a 1 hour, there is a rise of temperature of air by 50 degree Kelvin. We can consider as a 50 degree centigrade also, because linear scales, it is just addition of 273. So it's very huge. Means if you are at 0 degree in an hour, you have a something like 50 degree. So that increase in the temperature cause more and more heating, that cause more and more strengthening of low pressure area, that cause more and more rotation of the air. Because of the rotation, lot of moisture from the surrounding fetched into the, and it keep on doing in the positive loop, so that you will get a very good development of warm core, and that warm core basically gives a very large cyclone. Similarly, if you see, there is something called as rapid weakening, which actually weakens from uh, from here to here, because there is a decreasing because of it. If this particular shear, this particular structure goes under shear, you can see like there is a shear. The Because of the shear, this particular vorticity is keep on decreasing, and then asymmetry forms, and that asymmetry actually cause the decay of the cyclone. So these are the few fundamentals. This is another paper in review. So these are the few fundamentals we are trying to understand. Similarly, for the eyeball replacement cycle, where that initially eyeball is here, then slowly that eyeball disintegrate, and it forms like say two eyeballs, and then one inner eyeball will decay. So this is called as eyeball replacement cycle. So physical mechanisms for that we are using. This is all the story, but more than that, there is something called as a dry air intrusion, which cause another problem. One of the our paper in JGR atmosphere, we could show that the dry air from the top cause the increasing size of the tropical cyclone and delay its intensification, but it forms a more violent. If our Bay of Bengal, this is basically over the Atlantic tropical cyclone. If you consider the Bay of Bengal tropical cyclone, where the dust is not there, that that is not forming, like there is no intrusion at the top, and therefore it rapidly intensify and decay. So cyclone is strengthening due to dry air intrusion, but cyclone is weakening also due to dry air intrusion. For example, this is a famous Oki cyclone. You might have heard about it, or might have got impacted about that, which supposed to hit to Gujarat but decayed into the Arabian Sea. That is because of aerosol dry mass coming from the Mumbai, or that all pollution got into the lower region of the tropical cyclone, and once it goes into the lower region, it rise the air there. Some air was whatever going inside the tropical cyclone was not moist, and then it killed the tropical cyclone. So these are the various mechanisms we studied, and then trying to understand that. So I will now, there are a couple of slides. I think I have more 5 to 10 minutes, I hope. Uh, so, so, so what is happening over the years? We try to understand, and this is one of the paper by Wang et al. This is a in Nature recent paper, and if you see that the changes in the tropical life, there is a changes in the tropical cyclone life cycle and rapid intensification. Now, this is the famous Gaussian curve you are seeing, and this blue is for 1982 to 1999, and this is for 2000 to 2018, and you see that there is a shift. Similarly, you can see here that probably this is a probability of rapidly intensification and rapid weakening. So if you see rapid intensification is increasing, rapid weakening is decreasing, and because of that, a tropical cyclone will hit to the coast with large intensification, causing a more damage. So it is very important to form a very important to have this understanding, because tomorrow it may happen that we will predict that like some of the people may be having idea that tropical cyclones gives lot of rain, so we will get a lot of water. That is true. It will be very useful, but if we never construct the uh, our uh, our infrastructure around the coastline in proper way, which can sustain the shear given by the tropical cyclones or the changes in the pressure fluctuation in the tropical cyclone, then it will become difficult, and we need to have always a repetitive investment for various structures we develop around the tropical cyclone. So theoretically, we need to work on that. For that purpose, at NARL, we have started something called as numerical observatories at in our petascale computing system, where we are continuously monitoring and seeing that what are the damage potential of various tropical cyclones, and there we are trying to study the rapid intensification, rapid weakening, as well as the amount of shear it will got. So if intense cyclone hits the tropical cyclone coastal region, it definitely going to impact all of us. But uh, if it is weakened cyclone hit to the coast, definitely we'll get less damage and good rain. So we need to look into that, what is seen prospectively, and look into fine-tune models to see these changes and those non-linearities into the model. So if you see this black color indicate this is another paper in PNAS by Kosi, where they have shown that these regions are getting impacted by the tropical cyclones. And if you see on our North Indian region, there is a increase of transitional wind speed, means in the sense that rapidly intensify flying. However, the other regions there is a decrease other than this in Eastern Pacific, and this decrease and here is the increase needs to be simulated. Similarly, another paper, this is in PNS by Murakami, also showed that the spatial patterns and trends likely to be explained by multi-decadal variability and climate, and then the greenhouse gas, aerosol, and volcanic eruptions plays a very important role, and therefore the changing climate also cause a lot of changes in the life cycle of the tropical cyclone. So tomorrow, if we want to have a climate resilient India, we need to look into this very deeply and then come up with the policies how we can develop our coastal structure, and then how we can have a assess the damage potential and then come up with the understanding with our theoretical development, with changing our equations and simulating them, refine tuning them, and then one day a very good model we will have that will help us to guide people that, or the guide policy makers, that how they should go about the development of the form. With this, I thank you very much. And most of you are research student. I like to really welcome you to look into some of these aspects in terms of there are, because it is a global phenomena, and an ocean atmosphere coupling, and even biology in the ocean is affecting the cyclone and so on. So it's really good to have. If you have some questions, I would like to uh, answer them. Thank you very much for the patient hearing.
Thank you, sir. Thank you for wonderful speech and lecture. So now the session is open for discussion. Please, participants, please interact with Dr. Amit, sir. Thank you.
Thank you, sir. Sir, there are a few questions on the chat box.
Yeah, can you please explain NIO tropical cyclone? I think North Indian NIO is the North Indian Ocean tropical cyclones, and I think I can go to slide. Yeah, you are getting my presentation? No.
No, sir.
No, sir.
So I think here, so these are the North Indian tropical cyclone form. Now, if you see how a tropical cyclone forms, this is something called as the anticyclone 1 and 2, and they move over Africa, and this African anticyclone actually caused the dust intrusion in Atlantic, but same anticyclone. When they are in pre-monsoon season, means March, April, May, it is here that moved there, and mm, this is basically another anticyclone which moves in October, November over Indian region. Now, there is one more phenomenon called as MJO, which moves from equator towards east. That though these tropical three phenomena actually doesn't allow tropical cyclone to develop. Now, what happens is suddenly, uh, suddenly, in such a wave structure, the small vortices like this forms, and this vortices, actually this animation is of tropical cyclone Agni, which forms very near to the equator, and people say the Coriolis force is the very much important to get the rotation. So then why equatorial form cyclones forms? It is not only a single cyclone or the single cyclone forms over the equator, but there are more than 22 cyclone forms over the equator. So if Coriolis force is zero near to the equator, uh, then how they form? So what is important is more than Coriolis force, this rotation or the rotation of air, total rotation of aerial thing. They really bring back such a small thunderstorms, what we can say, and then they collide, merge, and they form. So this is a theory which is we have explained over the North Indian Ocean, but one of the with the hypothesis which is basically led from the Montgomery, and then we have written the equations and all. We have solved about this. So there are many such a thing, and North Indian Ocean tropical cyclones they form like this. So wave structure is somewhere here, and they originate here, and then once they originate here, they try to move here. or try to move here. Now, because of the movement of wave structure, this particular anticyclone moves here, and this goes towards Pacific, and in between, tropical cyclone gets away or the path, and they moves and hit to the coastal region. So this is how most of the time both pre-monsoon and post-monsoon we need to look into. Now in monsoon season, what happen is there is a shear, so even cyclone forms, it not intensifies above cyclonic storm stage, and we generally call them as a depression. So this is how they form. So North Indian tropical cyclone has a thing, and you have seen that total number is increasing over Bay of Bengal. Annual number formation is decreasing. Arabian Sea it is increasing. That is because of ocean is getting heated, and there are so many theoretical answers for this, but needs to be validated thoroughly and really needs to be do the research. Similarly, if you see pre-monsoon period and post-monsoon period or Arabian Sea increasing, but if you see Bay of Bengal, pre-monsoon is same, but post-monsoon is decreasing. So there is the changes in the ocean and changes in the atmosphere. They forms, they really impact the uh, atmosphere, this formation of tropical cyclone. There is another question. Uh, Sir, tropical cyclones are influenced by global warming condition in the relation to variation of included radiation, reflection, greenhouse concentration, SST, with the inherent correlation. How does the westerly easterly shift towards the pole causing the impact on mid latitude region? Basically, what happen is there is this or you might have heard about something like the bulging of Hadley cell. Bulging of Hadley cell is basically because of the global warming. Therefore, what is happening is the all of you know that where the Hadley cell start over the equator, there is a large convection, and then where it goes around 30 degree, goes down around 30 degree, where high pressure areas are there. There are the mainly um, mainly the subsidence, and because of that there is always a fair weather or good weather and less rain. So because of the less rain and fair weather, there is mainly forms a desert because less rain. And now Hadley cell is bulging. So presently we show Hadley cell from 0 to 30 degree, that if goes from 0 to 35 degrees in latitude, then there is a this shift. Now once you change this Hadley cell, bulging is happening. So whatever this subtropical easterly, subtropical westerlies and easterlies, they are interacting at 30 degree north, will shift to 35-degree north. So basically what will happen is then Ferrel cell will further shift up, and then polar cell become a weak. So majority of the tropical cyclones which are having origin, mid-tropospheric tropical cyclone having origin from the polar cell, and the instability into the polar cell, which become weak in the future, not distant future but long future. Then it forms a less intense tropical cyclones over mid latitude. So this is how this forms. So what they are saying is that greenhouse gas concentration increase in this warming, as well as sea surface temperature at equatorial latitude, will have the impact on the polar latitude. And obviously on our latitude, another thing is another that study showed that the slowdown of the motion of the tropical cyclone. Now this slowdown of the motion, which actually cause uh, either tropical cyclone to dissipate or near to the near to the equator, is less than a 20 degree. So it will also not going to hit the north region, and because of that, there will be less damage potential there. But majority time cyclones gives the rain, so it again reduces the rain over that region. So there is a complex mechanism of desertification will start there. Then another question by Soumya, sir, what is the difference between hurricane, tornado, and cyclone? Basically, if you see hurricane, tornado, and cyclones, all are same. They are names on different regions. Like America says hurricane, tornadoes over sorry, to not tornadoes. Hurricane and cyclones are same. Tornadoes are small thunderstorms. So tornado size is something like 1 or 2 kilometers but having the intense energy of 10 raised to 8 joule. But if you see cyclone and hurricanes, they are their size is 200 to 1,000 kilometers radius, and having energy from 10 raised to 12 to 10 raised to 22 joule. So tornadoes are small thunderstorms, but most intense thunderstorm. General thunderstorm having 10 raised to 5 to 10 raised to 6 joule energy of that order, but tornado having 10 raised to 8. So tornado actually cause the damage over the small region, but cyclone cause the damage over coastline like hundreds of kilometers. So they are different, but this kind of tornadoes comes together. Now tornadoes we refer into the over the land, but the over the ocean, water spouts is a part of tornadoes, as well as is a kind of tornadoes, and such a tornadoes come together to form a hurricane and cyclone. What might be the reason? This is very good question. Actually, if you see why Orissa gets the maximum cyclone, because I just explained that around 20, about 20 to 25. Now, first of all, we will understand that cyclone move because of the air motion above say 5 kilometer to 10 kilometer of that. So it is something like you have a trolley, and that trolley pushed from the top. So cyclone is also pushed from the top, and if you see above now, Orissa is just at the border where 20 above that there is something called as the westerly jet. That jet and the anticyclone, I will again present that slide here. These anticyclones, they move up to here, and this is the jet. This jet and anticyclone moves this side and this side. This jet doesn't allow it to go further, so it has to either turn here, and this region is coming around because this jet is over Delhi latitude around 20 degree, 20 to 30 degree. This is called as subtropical westerly jet, which actually they are from 7 kilometer to 10 kilometer, and to cross this jet, westerly jet, a lot of energy is required. So tropical cyclone cannot cross the jet, and because of this flow, tropical cyclone cannot penetrate further, even you see here, and so most of the time they have to go either Orissa or coastal part of West Bengal, Bangladesh, or Myanmar. So therefore this jet plays a very important role for restricting tropical cyclone over the tropics, not only over the India, throughout the globe. I don't have diagram to show, but I think here also maybe here is also jet, but for here you can see this is the jet. So these jets doesn't allow it to go further, but recent study says that it may go further, and even observations are showing like that. So therefore Orissa and that region, not only Orissa, Bangladesh and Myanmar region gets the maximum cyclone. over that. And then if these anticyclones, what I was showing, uh, these anticyclones, if they are stagnant here and they are not going upward, then whatever the cyclone form, they have to either go from this Chennai region and then they will hit Oman or Gulf. So they will show this directory. Or if this anticyclone moves here, they will go and hit Gujarat. So basically, these positions of anticyclone as well as the where cyclone forms, it actually determines they will hit, but maximum is at Orissa because of this particular jet is not allowing them to go ahead. Then another question by Soumya KR is in Bay of Bengal we can see this frequent phenomena, but rarely. Yes, it was true. Bay of Bengal is warm because of the lot of intrusion of fresh water, and always it is warm and conducive for the development, because I was mentioned in 20 in first part of my lecture, we need 26 degrees centigrade and above sea surface temperature. Bay of Bengal is always about 28, so it is always there to form a cyclone. It is always moist, so any instability develop, then thunderstorms will develop, then they come together to form a cyclone. However, Arabian Sea is, there is something called as downwelling is taking place, and because of that there is a cooling. Then a lot of dust from this region, uh, it is coming here, and there is something called a dimming effect. Means aerosols, they backscatter the radiation, and those backscatter radiation doesn't reach to the surface of the ocean, and therefore ocean gets relatively less temperature. And this relative less temperature causes the ocean cooling, therefore it is called as dimming effect. Means you are dimming your tube light, like that you are dimming the sunlight, and that caused the um, this this thing, that caused the decrease in the sea surface temperature. Obviously it really decrease the efficiency of the atmosphere to generate such a cyclone. There is a question, what can be done to improve weather forecast in India? uh, basically, weather forecast, if you see over the India, is really getting improved to the regional scale. But if the way the requirements are there, the expectations from the weather people are there. Uh, it needs to be do more, but most important is because most of you are young people, I feel we should have our Indian model for our region, because what happened most of the time, we are using something developed at NCAR or in NASA or somewhere, or European Union, but not in India. And we have started an efforts. We are developing something called as unified framework, polyhedron framework. It may be available soon for the people, and then we can keep on correcting the our codes, because what happens, somebody will do for their country with their assumption, their understanding for their country, not for us, and then we start to improve that, and we got into the difficulties. So we should start like cooking our rotis our own. That will help us over the years, like with academia and then many interactions. We will come up with a very good model which will help our country. So young people, like instead of taking ready-made, you start writing your own code. Do like we do ourselves in NARL, but most of the academia and research scholars has to do that, because many things are ready-made, but something like it is buying ready-made trouser, which may fit or may not fit. So these are the thing. Mm, we need to. So
Sir,
uh,
Dr. Amit,
yeah,
this is
yeah,
Anbu from Kamaraj University. How are you,
yeah.
sir?
I'm good, sir.
Okay,
Yeah,
thank you.
yeah, yeah.
Yeah, my question in connection with the question that you just answered, it looks like the Indian Meteorological Department took a decision 3 years back to make use of CWS second generation software
Mhm.
from, I think it is from NCEP, NOVA.
Yeah, yeah.
Are they taking, is that the only model they are referring to, or are they taking input from your institute or any other institute from India?
Yeah, basically, there are WhatsApp groups where all inputs are taken most of the time, but we have owners of giving forecast for the rocket launch kind of support. Now, what happened? The difference in IMD forecast and our forecast is IMD forecast is a regional forecast, and our forecast is a point forecast. We are not worried what will happens 10 kilometer away. We are worried what will happen to the launch pad, launch vehicle during launch, whether there will be thunderstorms and all that. So that is a point forecast. So if you improve the point forecast at each point, then definitely you will have a better forecast for whole India or whole globe. So this is the thing. So our approaches are different, but we consult each other. We also consult IMD, and some of the forum they also consult us. But that is there. IMD is using those models. We have developed our own models, but over the years they will be available for everybody. At this moment, they are not available for that. But maybe by 2022, I want to make it available for academia and many things, because there are many policy decisions related to that. And once, but we have promised, like when India's independence, 75th years of independence, we will release that. So 15th October 2022. So 15th August 1922, 2022. So we will release that, and that will, if we have a base, we can build upon that. Means it's like our own thing, and we are doing for ourselves. So that is our concept. There are 4 PhD people, six people. They are working on microphysics and cumulus physics development of using Indian thing. So we are, as a NARL, we are trying to develop this thing our own. It is hard way, but it is work to do. So we started, because if you see, I'm using all this global model and all from last almost from 1998. If I would have started there by now, we would have been matured, much matured. So and then when I will speak about modeling, I will say that my seniors have not developed their model, but they have used somebody's model. I don't want my next generation to talk that our people have not developed the thing, and that is where these efforts are started, and many people are supporting us in that. And definitely, uh, you are also welcome in some part of modeling. If somebody wants to develop, we will collaborate and finally bring up with our model, and over the years we will make it perfect with our assumption, because we see and we can assume what we see. Whatever the foreigners are seeing, they will see and they will assume related to that. So there are the, and everything is not known. Means 100% we don't know either at mid latitude or on our region. So we need to have to come together to form that, because we are different than mid latitude. So we need to work on that is thing.
It's good to know, and it's good to know that you have some initiatives on that front, sir. Wish you all good luck. Thank you.
Thank you, sir. This is, I have isolated fish rain. Yeah, fish rain and all is because of the actual fish at upper layer of the ocean. Basically, they sucked by the high wind speeds, and they are actually water is in water spout. What they are, lot of energy is there, and whatever come in between water spouts will be fly into the atmosphere, uh, and they even hurricanes and all, it depends on the instability develop, and from what level layer of the atmosphere or whatever the ocean the things are gets sucked. If you have a intense hurricanes, definitely fish rain happens, and it is known. Even big fishes like the big fishes like shark and all also get killed during that, and if they comes below low pressure area and in the eye wall region. So definitely hurricane affect that. uh, if fishes and hurricane, there is a question: is there any way that these fishes or other organism to survive in these deep? Yes. Basically, you are from life science, most of you, then you know that fishes and organisms can be survived, like mango. If you develop mangroves or those kind of plants, and which actually doesn't allow low pressure to damage, because what happens that low pressure, as far as it is in the rotating motion, it has a strength. But if some buildings or some plants comes in between, the channeling of the wind is taking place, and then circulation breaks. So this used to breaks because of the mangroves and other thing. So if there may be a very good mangroves developed at some region where hurricanes are getting impacted over some region, and especially near coastal region, then definitely fishes will also survive, as well as hurricane will not hit to the coast with the large impact, with the large wind speed. So there is a this one. And if yes, how things? There is some network problem, I hope. So, okay.
Yes, sir, we
So,
can hear you now.
okay. And there is another question. Is there any science that explain the influence of hurricane forward on the storm cell generation at open coast and bay? Yes, there is a established science. There are many papers on this which explain the influence of hurricane forward speed on the storm surge generation, but nobody has measured actually what happened uh, in reality. Therefore, what we are trying to do is, and I was just mentioned that we are trying to establish Arabian Sea and Bay of Bengal numerical observatory. In that, we are going to establish a few coastal stations which will only during the hurricane day, when tropical cyclone hits to those regions, because those stations will be may not work for the longer time, but they will have capacity to sustain the winds at that particular winds, that particular scale, and those we are trying to measure. So surge is getting measured, but wind shear and pressure drops due to the which cause the major damage, they are not getting measured, and those are the problems. Most of the French models are through use the shallow water equations. Those needs to be improved, and have a three-dimensional equation that needs lot of work and measurements. So some measurements IMD is making, but we are going to go to coast to measure those actual wind speeds, wind shears, and density fluctuations in the pressures, and then their impact. Then something called as large eddy simulation we will use to find out the impact of a cyclone on the coastal structure. And then we are bringing out the research paper that will help policymakers to what kind of structure should be there for the future development, so that we can save the repetitive damage. So this is efforts are there, but still shallow water equations are used. This is well established, but we need to have a very good validation. So that is not yet done. So I think most of the question I answered. If anything, otherwise, thank you very much for your patient hearing.
Thank you, sir, for wonderful discussion. Thank you, sir. Thank you very much. And, you have replied all the questions. I think today we had more than 25 minutes interactions. 30 minutes interactions. Thank you, sir. And we have a 10 minutes break, and we will come back, sir.
Okay. So at 12 o'clock?
At 12 o'clock, okay, sir.
Okay.
Okay,
so 12 o'clock we start the practical.
Yes, sir. Yes, sir. Yes, sir.
Okay.
Thank you
very much.
Thank you, sir. Thank you, sir.
Okay.
Okay. Participants, we will come back by 12 o'clock. Inder. யாராவது ஒருத்தவங்க ஓட் ஆஃப் தேங்க்ஸ் சொல்ல சொல்லுவோமா?
ஷூர் சார்.
பண்ணலாமா? கேட்கலாமா?
எஸ் சார்.
அவங்க இருக்கிறாங்க இல்லையானு நமக்கு தெரியல பாருங்க.
கரெக்ட் தான் சார்.